Application of trigonometric ratios. Well, this is a thinking problem. It's quite difficult. Door of a glass house was designed as an equilateral triangle of side lengths of 4 meters. Over a period of time, one of the corners of the door sank 55 centimeters into the ground. Determine the perimeter of the exposed door. Okay, so first let's try to sketch this, right? Let's say we are considering here even ground. Let's say this is our even ground, and the glass door is of kind of triangle, right? And we'll assume that it sank 55. So let's say this is the 55 centimeters of sinking, right? And let's say then finally, it is 4. It's an equilateral triangle, so this is the door side which sank 55 centimeters into the ground. That's the ground level, right? So now our equilateral triangle will be kind of tilted, right? So let me draw this tilted triangle in this fashion here. So let's say that's one side, and let me just join this with this and that. How we get our equilateral triangle. So all these sides are 4, right? Now this length is also 4, correct? Now the sinking is 55 centimeters. So let me call this as 0.55, 0.55. All the units are in meters, okay? Now that is how the triangle looks like. Now what we need to find is the perimeter, that means of the exposed. That means this is 4, we know, and that is slightly less than 4, and we will not consider this side because that is the exposed portion of the door. So we need to find this length. If we know this length, then we can take away this length from 4, and we know, well, it is that much less. Now to figure it out, what can be done? So one thing is that we know it's a right angle triangle, this small little triangle here, right? So this is 55, and that is a right angle with the ground. And let us say that this angle for us here is D. Let us call this angle as D, correct? Now if this angle is D, then, and we know this height as 0.55, we can find the length, let's say L, which is from here to here, correct? Now so if in this small triangle, if you see this angle is D, so that becomes adjacent side, right? So we can say cos of D is equal to adjacent side of 0.55 over L, right? So that becomes the relation between the angle and this side. Now one more thing which we can see here is that now if you consider this triangle, let me label these points. Let's say the triangle is A, B and C, and we'll call, okay, angle, okay, A, okay, now let's say this point is P and this point is Q for us. That point is Q for us. Now if you consider the triangle A, B and Q, so that is a right angle triangle, right? So in that triangle we can figure out what is the length of side QB, correct? So we can find what is the length of the side QP, correct, from this triangle. Since we know this is 4 meters. Now we know, okay. Now let's consider triangle ABQ. So that is a right angle triangle with 90 degrees at Q and AB as the hypotenuse, correct? So we can find the angle at A with the help of that, right? So we can say the angle of A, that is cosine A, will be equal to base is 0.55 over 4, correct? The whole angle A. So we say cos of A in this triangle, let's consider this triangle, cos of A is equal to 0.55 over 4. That becomes the hypotenuse. Do you see that? And therefore angle A is equals to cos inverse of 0.32 second function cos inverse of 0.55 divided by 4, which is 82.096, right? So angle A is this. So angle A is cos inverse of, so from here we can say angle A is cos inverse of 0.55 over 4, correct? So we get that angle A as 82.096. So 82.096 is actually the whole angle from here to here, correct? That is the angle. Now from here we know this is an equilateral triangle. Since it is equilateral triangle, all these angles are inside the triangle are 60 degrees, correct? All these angles are 60 degrees, correct? So that means our small angle D is equal to A minus 60, right? So we can from here say what is D. So we have angle D equals to angle A minus 60 degrees, correct? Which is 82, we can say 0.1 minus 60 degrees, correct? That gives me 22.1 degrees. Now we know angle D, right? So we started with cos D equals 0.55 over L. So now we know what length L is, right? So from this equation we can now write what is L. So L is equals to 0.55 over cos of angle 22. So cos of 22.1. We can calculate this using the calculator, right? So we have this as 0.55 divided by cos of 22.1, which is 0.5936. 0.5936. So that is this length, 0.5936. We can say 0.59, correct? Now if you know this length L, then we know the remaining length which is exposed, right? So that means exposed length, that means C to P, is how much? So this implies that the exposed length CP is equals to 4 minus 0.59, right? That is, so we'll do 4 minus 0.59 equals to 3.41. 3.4. And therefore the perimeter of exposed sides is equals to this side of 4 plus 3.41, which is 7.41 meters. Okay? So that is how we can actually calculate this problem, right? We can find the perimeter of the exposed sides. So that's how we can do it. I hope you understand how we approach this problem. Initially, you took a equilateral triangle of 4 sides, 4 meter side lengths, and the angle inside will be 60 degrees. Since one of the corners sang 0.55, so we just analyzed that corner, and that corner formed right angle triangle with QAB, and that helped us to find the total angle A, and from that total angle A we found the small angle D in that little triangle, which helped us to find the length of the door which was under the ground. And then that length, when we take away from 4, gave us the exposed length, and when we add that to the other side, we know that the total parameter of the exposed door is the sum of these two. Okay, so that's kind of tricky and a very good question to do. And I go through this. I hope it helps. Thanks.